All right, so last section we talked about some graphs with categorical variables. We talked about the histogram. We talked about the pie chart, or not the histogram, the bar chart and the pie chart. So today we're going to talk about some graphs for displaying quantitative data, numbers and things like that. So the first one we'll look at is what's called a histogram. Histogram is really good for quantitative variables. But the problem with a histogram, with a kind of a bar graph for numbers, is you have all these different numbers. It would obviously be very difficult to actually put all of the numbers in their own little categories. So what we do is we typically will divide the data into different groups. So we'll say from this number to this number, or this number to this number. And these are what we're going to call classes. Now the most important thing when you're making these classes, you want to make sure that you have things that are equally spaced out. So you don't want to say, I'm going to look at ages of people and go 0 to 5 and then 6 to 50. That would not make a lot of sense because one is so much bigger than the other. So that's not something we want to do. We want to kind of keep them equally spaced when we do this. So when we do this, when we keep these equally spaced things, we'll make a frequency distribution. Now, a frequency distribution is simply going to basically be, it's going to be our classes with how many in each class. So we're going to do our, how much to this, to this, to this, to this, and then we're going to figure out based on that, how many are in that, okay? So when we do this class width, it's really easy to make a histogram because a histogram in general is just going to be kind of a bar chart just with these classes. So let me show you how this works. So I'm going to look here. I have some data here. These are the record high temperatures in each state. So if I look at this, the first thing I'm going to do is look for the smallest number. It is 100. And then I'm looking for the biggest number, and it is 134, okay? So if I look at the difference between the biggest and the smallest, that's a difference of 34, because 134 minus 100 is 34. So what I want to do is I want to divide this by how many classes I want. So do I want, 2 classes? Do I just want 2 groups and then put them in 2 groups? Generally speaking, you want somewhere between 5 and 10 different groups. If you have a lot of data, like we have 50 pieces of data here. So I want somewhere between 5 and 10. So I have 34. 34 doesn't divide nicely by any of those numbers, but it gets close, right? So if I say I want 5 groups, let's do 5 groups, or 5 classes. Then I'll just take 5 divided by 34, which is 6 point something. I don't really know, don't really care, because I'm always going to round up. So 7. So my width, so this is what we're going to call the class width. This is how wide we're going to do each group, okay? So if it was exactly 6, you should still go up to 7. If it was 5.9, then you can round up to 6. But I know this is 6.8 actually, if I want to be exact. And 6.8 I would round up to 7. So always round up to the next whole number, and that's your class width. Now this class width is important because this is how we are going to, this is how we're going to start doing our table, our frequency table. So I'm going to have our classes here, and I know the smallest number is 100. Okay? Now, this class width we just found, very important, it's 7. So what I'm going to do is take 100 plus 7. So I get 107. And then I just keep adding 7 each way down. So I'm going to keep adding 7 to this number each time. Okay? And there's my 5 classes. Because I decided to have 5, right? I could have done 7 or 6 or whatever, right? But I decided to do 5. Now what I'll do to end the class is, since this number is 107, one number less would be 106. So the first class is going to be all the temperatures, all the states that have a temperature between 100 and 106. And now we'll just start adding 7 to this other number. So 106 plus 7 is going to be 113. Add again, I get 120. Add 7 again, I get 127. Add 7 again, I get 135. Now, if you notice, the way we set this up, all our data from 100 to 134 will have a place in this graph, okay? It will have a place somewhere here. But just remember, the thing people generally mix up is these are the class widths, right, between each one. These are going to be my class widths. That's the thing I'm going to calculate to figure out how much I should space those out. So now what I'm going to do is I'm going to find the frequency, which is basically like a count, like how many are in each one, right? So first I want to look how many are between 100 and 106. So generally what I'll do is I'll just start crossing them out. Anything that's between 100 and 106. And you got to be very careful with this because you could certainly miss them. So I think all the ones I scratched off are between 100 and 106. So that's 1, 2, 3, 4, 5, 6. So we have 6 that are between 100 and 106. Okay. Now I'll do between 107 and 113. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I believe that's 16. And if I did it wrong, you get the idea. So let's look at between 114 and 120. So that's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And I just found there was another one. This 109 has got to go up here, so that's going to be 17 now. All right, 121 to 127. So let's see. So 127, 121, 3, 4, just 4 of them it looks like. And the only one that's above, it's in the 128 to 134 range, or is this 134? So we'll have one of these guys here. Now, I could add these up because these are states in the union, so this should add up to 50, and if I add these up, I do get 50, okay? So, I put the data into classes, and now I know how many are each one. This will help me make my histogram. Now, a histogram, again, is just going to be a fancy bar chart. So what I'm going to do is I'm going to start with a horizontal line here, and then I'll put another one here, okay? So this is going to kind of be my axes. And I'll put one there, put some things there. So what I'm going to do is on the axis, I'm going to put these numbers. So I'm going to put the 100 and the 107 and the 114, the 121, the 128. Now the weird thing is you actually have to put the end of the 128 bar, which is going to be 136 or 130. It's 135, yeah. So, and then we'll go ahead and we'll make our bars, right? So the first one has 6, right? So maybe I'll go by 2s. 2, 4, 6, 8, 10, 12, 14. This is 16, 18, 20. So my first one only has 6. So what I'll do is I'll make a bar that goes up to 6. Okay. Between 107 and 113, it's 17. So it'll go something like this. Between 114 and 120, that is the 21, so that's like our tallest bar, so something like this. You can see it's like a bar chart, but we do make the bars connect because it's continuous data. There's 4, and there is 1, little guy there. Okay. So this is a histogram. Now, obviously, we should label it. This is our temperature. Assume it in Fahrenheit. And this is our frequency. Frequency, remember, is just a fancy word for how many in each group. And we should title it somehow. We could title it, I don't know what you want to title it, temperature or something, I don't know. Something not very unique. So something like this, okay? So these would be our ones, right? Now Now, I like this histogram because we can ask questions about the histogram, and some questions with a histogram are very, very difficult, right? So the problem with the histogram, and I think you'll see it in this first question, it says, what states had a high temperature over 110? Well, the problem is when I look at this, I know these are all over 110, and I know these are all over 110, I know these are all over 110. All those are already over 110. But the problem is I don't really know how many of these, because 110 is in the middle, right? So how many do I really know? I really don't. Now, I could, of course, go back and look at the data, but if you're just given a histogram, this is one problem with a histogram. It kind of does group things together, so you don't actually know all the individual data. So what I could say is it's at least, well, I know 21, 4, and 1 is going to be 26 out of 50, which is about 56%, I believe. No, it's 52%. So it's at least 52%, but again, this bar here, some of them would be 110. So if I wanted to be exact, I'd have to go back through the data. So sometimes histograms, when you group them together, do cause some issues. All right, so let's look at some other parts of a histogram, some things with graphs we want to keep in mind, and things that we'll look at not only with graphs but more mathematically in future sections. So obviously one of the biggest things you want to look for is patterns, right? Trends you see in the data, right? So what is happening is, is most of our data around a certain number? Are there a lot that are bigger, a lot that are smaller? What's going on? Is there some that are kind of goofy, or are they all about the same? That's kind of our idea. Okay? Now, in that respect, we also are going to talk about what are called outliers. Now, data that is an outlier is just a piece of data. So it's one piece of data, it's one number that is much bigger or smaller than the rest of the data. So it's going to be a lot bigger, a lot smaller than all the data, right? So if we look at a histogram, so we can look for outliers, we can look for a histogram or for patterns. So here is a histogram. This was, someone counted how many different characters were on a page of text. So many letters and periods and explanation points. So if I'm looking for patterns, I can see that most things had their data somewhere between 25 and 275, right? Most of the data is kind of in that region. But I can definitely see that there might be some outliers like this. There was one thing that had like 625 elements per page. That's really, really, really high, right? So that's probably an outlier for sure. So what about this one? It's further away, not so far away, so it might not be an outlier. It might be an outlier, hard to say, but something we'd have to consider. The other thing we'll talk a lot about is the center and the spread and the shape of a distribution. Now, the center and spread are pretty hard to do with a graph, but it's something we want to do informally before we start doing it formally. So the center of a distribution is obviously going to kind of be the middle of the data, right? Something that we might kind of consider an average or something, right? And the spread is just going to be how far apart are the data. So are all the data really close together? Or are they more dispersed? Are there some bigger, some smaller, kind of all over the place? Or are they all kind of congregated around one section? Okay? So that's something we'll look for quite often when we talk about center and spread. The other thing we'll talk about is shape. Now, shape is something we do a lot with the graph. Center and spread, we'll do more mathematically with some formulas and such here soon. But the shapes of the distributions are essentially these different distributions you see here. So one of them is symmetric. So a symmetric distribution is kind of a histogram where it's kind of equal on both sides. So you kind of see the same things happening on both sides of the graph. So if I look at this bar, if this line here, on both sides, it's pretty equal, right? Now, it doesn't have to be perfect. Nothing, typically real world data is not going to be perfect. It's not always going to be perfectly symmetric, but close for sure. Now, some other shapes are what we call uniform and skewed left and skewed right. So if I can make this work, get this down here. This is what's called a uniform distribution. Now, this is a perfectly uniform distribution, right? But in a uniform distribution, all the classes have similar frequencies. So basically, each class I had, right, each one of the groups, they basically have the same amount of data in it. Okay, so in this one, it looks like they're all 3. There are 3 data pieces in each of these classes, 8 to 16, 16 to 24, and et cetera, et cetera. Again, it doesn't have to be perfect like this one. Anything close we can typically call a symmetric distribution. So our other 2 types are when we skew data. So we have skewed left and we have skewed right. Now, if you look at it, it's kind of a backwards way of thinking. In a skewed left data, most of our data is actually on the right. But we have a few outlier pieces on the left. You can kind of see that the graph kind of tails off in this direction, kind of tails off in the left. So these bars that are kind of much smaller than everything else kind of skew it to the left. When you skew right, your shape, we're going to talk about when we have a few outliers, or not even outliers, just bigger values on the right. So you can see some of these values are on the right, but again, most of our data is on the left. So it's kind of an odd thing to think about, where if it's skewed left, most of your data is on the right, but if it's skewed right, most of your data is on the left. So the skewness kind of comes from where are the kind of weird outlier points and which way are they skewing it. Okay, our last kind of graph is what's called a stem plot. So a stem plot is going to be where you try to have a graph that instead of a histogram where we kind of lose all the data, we're going to try to keep some of this data in our stem plot. So how we do it is you can see here there's a bunch of data. Okay, so let's just take, these are scores on a quiz in quantitative analysis. So I'm just going to pick the last one, which is 19, right? So what we're going to do is we're going to split this into 2 parts. We're going to split it into a first part and a last part with a vertical line. So 1/9 is really 19. So this is what we're going to refer to as our key. And every stem plot needs a key. It needs to tell you what I'm looking at in my graph. So a 1 on the left of a line and a 9 on the right really means the number 19. So what I'm going to do to make my stem plot is I'm essentially going to start with a vertical line. I'm going to make a vertical line here. And then I'm going to look at the first number in each one of these. So the first number I see, our lowest number, is 9. So I'm going to put a 0 here, okay? And this is the only single digit number, so what I'll do is I'll do 0 with a 9 on the right of the bar. So this represents the number 9. 0, 9 is 9. So now I'm going to look at all my numbers that start with a 10, like are kind of in the tens place. So quite a few, right? A lot of these are in the tens place. So what I'll do is I will put a 1, because that's the first number, and then I'll just list the numbers, the second digit as we go. So we have 10, 12, 13. Now, quite honestly, I should probably try to put these in order, which it's good now, but it's not going to be. But for now, for our purposes, 17, 15, this is fine. 10, 15, 17, 18, 19. And there's only 2 in the 20s, so that's a 2 with a 0 and a 5. Now, these are the quiz scores, so I'll put a nice title, right? So this is a stem plot. Now, the nice thing about a stem plot is I know every single data piece. I could go backwards on this, right? So I have 10 and 12 and 13. I know what these mean. I lose none of my data like earlier we said for the histogram. They all get grouped together. It's very hard to see. But what we can do is if you look at this stem plot, we can almost build bars around these to kind of make kind of a really quick kind of histogram. So if I look at this, and rotate it this way. So now it's kind of like our histogram. So you can see it's pretty symmetric. You got most in the middle. Obviously, most of the data is in that middle bar. But you could almost see the histogram kind of shape just from this. And if you have more data, if it was more if you had more variety of your data, then obviously it would look a little different. But a really nice, quick way to get that done for you. Okay. So just a couple quick quantitative graphs. Obviously, when we come back, we'll do some on sheets. We'll look at how we can make these work before we start doing more a little more mathematically. If you have any questions, please let me know.